I'm Leif, and I'll be talking about the importance of object-oriented programming in video games. So, game designers, game programmers, I'm not going to say that they're against object-oriented programming. Everybody loves object-oriented programming. They just hate to make objects and code object-oriented programming. People like calling functions, static variables, making objects that other people make, but they don't like to write out a new object for the thing that they want to do. And it is understandable. One, objects are slow to write. They have to each have a header file for what functions you want to use in other places. And you'll probably have to include something like the base class, or let's say you wanted to have a function that writes to a file. You might want to pass in a reference to a output stream. But then you would have to include the O stream up here as well. Similarly, inside of our source code, we're going to have to include some other things that might be specific to our uh, function bodies. So it's a bit slow to write, and every time you make an object, you'd have to do this. Inside of my game, I made a tree that doesn't move, and I'm not going to make another separate object. Just if it doesn't, one, do anything, and two, if the base object already does nothing, you know? You're going to want to make an object any time you have some sort of behavior that is new. Another reason why people don't do object-oriented programming is because it kind of didn't exist for a long time. Like if you were writing a game for the Game Boy, you know, these tiny microprocessors, which are normally the cheapest ones off of the shelf, they have their own unique instruction set. So normally for each console, you can have like some really weird processors, so like some vector math stuff that'll do like four numbers at a time, and they'll share info between each other. So you're kind of forced to write in assembly, and of course you can't do object-oriented assembly. Another reason is that object-oriented code is uh, hard to serialize. So imagine you're running a multiplayer game and you want to send your data over to the other guy. Now you have like maybe 20 boxes and you want to send all the boxes over there. So in a non-object oriented approach, it'd be easy. You'd have a list of boxes and you just send over their rotation and their position, and the guy on the other end will probably get them. It's a lot easier if we think about this as the boxes having like a struct of that data. So each box would have the position, orientation, and maybe the texture model or whatever. But when it comes time to objects, imagine you have just in your game a list of objects. They're all just thrown in there at random, maybe even mixed up. If you try to send that to the other person, they're going to have to probably scrape off whatever enumerator that the compiler puts in there to differentiate the objects between each other. Now, without object-oriented programming, if we go, it's the old code. So we'd find something specific about the object that we'd like. So here we say, oh, if the sprite is a butterfly, then we're going to apply the butterfly behavior, which is just adding a little bit of jitter to it. I'm going to switch over to that game before. So here is my before game. This is before I added object-oriented programming to it, and there's not going to be a big difference between the two, especially because in object-oriented programming, in procedural programming, you can do the same thing as object-oriented programming. It's just a different way to code it, except for these frogs. See how these frogs aren't doing anything? Uh, that's because if I wanted to get them to jump, then I would have to tell the frog that it's going to jump. The frog has to know where in its life cycle is the jump. So in any given frame, it doesn't know if it's about to hit the ground, if it's stationary, like if it's not jumping at all, or if it's on the way up. These butterflies, I just give them a random vector and I push them every frame. They don't really need to have any memory. They just have to know where they are on the current frame and then adjust their position accordingly. So that is one of the upsides of object-oriented programming. The object has its own data that it memorizes, and you can give it anything. You can give it, in my frog, I give it the place where it jumped from, place where it's jumping to, start time, end time. Also give it some private helper variables. So if I wanted to know if it is currently jumping, then I just tell if the current time is 1 second or in the middle of 1 second after the start of the jump. Another thing is inheritance. You don't want to be coding the same object over and over again. Like if you had a player and then you wanted to make an enemy. An easy way to make an enemy is to just take the player object and remove all of the controls and just give it a brain dead AI that, I don't know, shoots the player. Now, this is a lot more easy when it's some sort of game that's built for multiplayer. Like normally, if you're making a 8v8 couch co-op game, then you would want to first build out your local multiplayer stuff. But then if somebody wants to play single player, then you have an AI possess the player. So you would have an AI object that would be a child class of your normal player, and it would take control of all the controls. Another thing with object-oriented programming is that it's simplistic. When you write code for a project, a group project, it's a lot easier for other people to know what your code does if you can write it out. So if you made a function that says like create frog, if we go back to it, made a function that says create frog and it returns a pointer to the object, it's kind of difficult to know like what do I do next? Inside of my code, where is it? Game CPP. Oh wait, is this the new code? Oh yeah, this is the new code. So inside of the game, after we make the object, we're gonna have to scale it up or down. And yeah, you'd normally put that in the function, but people kind of don't know, like, am I supposed to do this? Am I supposed to do something to this pointer? Am I supposed to free it after I'm done? But if you make an object, then it kind of just becomes a thing. And then after it goes out of scope, it automatically clears itself. So there's a lot less of a burden for the people who have to deal with code that haven't written that code, people who are unfamiliar. There's also easier memory management, like I said before. Classes will have destructors, and if you want to put some dynamic stuff on there, then after it goes out of scope, then it'll automatically clear it. Also with components, let's say that, I think inside of my, so it's not here, but like imagine we had some other variable, like public. Actually, we could do this with a member. We say like string, or maybe a vector. Vector of strings. So what will happen is that if you have another object inside of an object, also including the inherited objects, it'll create them, and then once it gets destroyed, then it'll destroy them along with it. So if you have to have a struct, you might have to do that by yourself. You might have to call delete or something else. Probably still will. But also in objects, all of your delete statements will be in a destructor. I didn't make any destructor here because there is no dynamic memory stuff inside of my objects. So, what does the updated game look like? So I got the frogs to jump, and all they do is they just jump, and then they'll decide another time to jump again. It'll have a little bit of a variance to it. And I'll switch around the sprite, and also note that in the other approach, if your sprite changed, then also your behavior would change. You could probably make some sort of like state machine to know if the frog is jumping or not. But also, imagine if you wanted to make a bullet that just had the sprite of a frog. Then you'd have to probably make another sprite. And if you wanted to get around that, you could make an enum. But by the time you're making an enum, you might as well just make an object. So I guess they've hopped off screen. See my... So the way to do this is by adding a way to put your own pointers into the object manager. So over here, instead of asking the object manager for a pointer, it feels a little bit better. It feels more assertive. Like I'm making a player. Here you go, object manager. Good luck deleting it. Also, with the create, like it says like create add turret again. If it's just going to be a picture, you might as well just leave that in there as it is. Inside of my object manager, I also leave the create function in there just as a little bit of backwards compatibility. But it is nice to add your own objects that have their own behaviors. Let me see. Also, yeah, a big thing is command query separation. So with our add, since we're not having to ask for that pointer back, so we want that pointer to the player after we make it. So this kind of waits patiently while it creates it, and then it gets a pointer and it gives it back to that player. But the benefit is that without that, we can make the pointer to the player. We can store it, we can do whatever we want to it. We could even change the size or, I don't know, like start a function, call a function. But then afterwards, we can just give it to the object manager and not have to rely on it to return any data. That way, we can separate our accessors and our mutators so that it's a lot more nice, neat. It's also a lot easier to debug if you know that, oh, this function shouldn't have changed anything because it's only an accessor or it's only a mutator. So that was this page. Cool. So let me go file by file. I'm going to start with the ones that I actually change. These are the new files for all the objects. So inside of game, that's what we saw, I think. Wait, no, this is Okay, so this variance is just a little bit of variance I give to the butterflies. That's how I spawn them. I put them in a loop. Since I make an object, this could be done with like a creator function, where if I want them to call a function to make a butterfly, then I could do like pObject manager and then also call the x scale and the y scale inside of a function. But it's a lot easier on the eyes to just make a butterfly object. And the butterfly object, it doesn't even tell you like what it does. It's inside of the constructor up here, and it does little secret things. Also in my frog, I do a couple other things like set the start jump time, and I make sure that it doesn't call jump immediately after it spawns. Let me see, where did I go? Yep, so that's that. Uh, you also don't have to worry about like losing. You don't have to worry about the names of your variables or leaving any variables in the scope. Like imagine if you wanted to use frog multiple times. Like here I can only make one frog pointer. Then I'd have to reuse it if I wanted that frog again. Or I'd do frog 1, frog 2. But over here they don't have names. They're just frogs. Okay. So here I'm going to admit this p move was there before. And I had to replace it just to make some bad object-oriented or non-object-oriented programming. Lark Engine is actually really object-oriented programming oriented. So inside of everything, also let's go to object. They have these move functions. I think these might even be virtual to begin with. I don't know why they're not. But a lot of things will have like virtual methods, which means that they kind of intend for you to inherit from them and build off of them. So if you're thinking like, oh, this is some weird stuff that I'm not supposed to be doing, no, they fully intend for you to inherit and override the move function. That's what we're doing here. Before, I would check to see if the sprite was a butterfly, and if it was, then I'd add some jitter to it. Now we just tell the object to move, and if it wants to hop, it hops. If it wants to jitter, it jitters. All right, and then here, the only thing that happens is I add the add function, which lets me put whatever pointer I want inside of the object manager. I don't think I changed anything from there to there. Oh, that's probably just some automatic stuff. Butterfly. Oh yeah, we haven't talked about these. So the butterfly, I move the jitter into here. It just makes the vector and then adds it to itself. It's kind of a burden being lifted. Like, so when you're thinking about object-oriented programming, a lot of programmers would rather be like, I'm moving a sprite every frame, you know? Like I'm doing the thing that the computer is doing. But object-oriented programming lets you take a step back and say, the butterfly is moving, you know? Like instead of, it lets you abstract, but it lets you abstract out of programming, and it lets you think about the way that your objects just are in the game. I think I already did show you the frogs. But when the frogs are in the game, like this is when they stop becoming a thing that moves and they start becoming an actual object, something that interacts with the world. It kind of gives it some scenery, some ambiance. Like there is a lot of games that'll just have frogs on the ground, you know, they'll just be props that the world builder put in there. But if you have like, you know, the wildlife in Red Dead Redemption or whatever, it's just like whenever you're in the forest and you hear a bird, you know, and normally you'd think like, oh, that's just the sound they put in the game. But if you follow it, you'll find an actual bird. Like, this is the stuff that makes these virtual worlds uh, a lot less virtual. All right. We'll look at the frog code and then I'll let you go. So we store at departure, destination, jump time, start time. This is also probably only important if you are interested in how I made the frog jump. What was that? So every frame, I get the time, and I'll tell if it's jumping. If it's jumping, it is jumping if the current time is between in like the next second after the jump start time, and I make the jump start time a little bit before when it spawns in, so that it won't get called immediately. So it'll also decide on another time to start jumping, which will probably be the first frame. Oh no, wait. It'll decide some other time. So if it does decide to jump, let me see, where does it decide that? Jump. Okay, it decides that afterwards. So after the first frame, it'll jump internally. When it jumps, it sets the start of the jump time to the current time, and it plans ahead the next time it's going to jump. We also have the jump radius, which is how far it's going to land from the start. And since I didn't want it to land any closer or any farther than the jump radius, I just gave it a theta from where it jumped, and then we just make a unit vector from there, multiply it up to the jump radius, and then make a displacement vector. Then we just record where we left off from and where we're going to, which is where we left off from plus the displacement. Inside of the move, let's see. So what we do is, this is a function to get the position. Basically, like, you can think of airtime, because airtime is a single second, so it's going to be anywhere from 0 to 1, and that can be like from 0 to 100% done. So this is like a little progress bar saying we're at the departure location, and we want to add a little vector, and then by the time this airtime is 1, then this planar position becomes the destination. So it's like if airtime is 0 to 100, then planar position is departure to destination. But then also, we use this jump offset. This is a little parabola that just goes up and then down depending on how long it's been in the air. So this is our y offset. This is how we make it look like it jumps up and down. If I go back to the game. So really, it's taking a point, it's taking another point, and it's moving there linearly. But to make it look like it's hopping, then while it's moving linearly, we just make it go up and down. But we also do it in a parabola, so it's not just going up, down. And then, let's see. And then we switch out the sprite so that when it jumps, it changes its looks. And then, let's see. Yeah, we added the jump offset, set the sprite, and then if we're not jumping, then we set it back. All right. Hope this could be helpful in any games you might want to make. I hope this convinces someone in your team to start writing better code. That is one of the other things in the object-oriented programming. Have I not went over this entire slide? Anyways, so it will make undeniably cleaner code. Like, you don't want everybody to post their code inside of main or inside of game. You want them to put it in their own function, and also that decreases compile time. So it's not going to take forever whenever you want to make a change.